such that minus n is not an element of S. Okay? So this is the negated quantified predicate. And what about this? Is this true or false? Now we know that because the original predicate was false, its negation must be true. But let's just assess it. So this saying is that we can find some n and s that when we negate it, okay, or when we get the minus of it, that's not an s. And the example is 1 again. So 1 is in s. Okay, there does exist, there's a 1 in s, and minus 1 is not an element of s. So that's actually true. Okay, so we actually found something in there where minus it is not an element of S. So what we now have is that this particular statement here must be true. And we could have a look at maybe one final one. Let's say part 4. Okay, so let's have a look at one final one. So let's say IV, okay, IV, and let's say there is at least, okay, there is at least one n that is a member, okay, that is a member of S, okay, where with, or let's say with with the property that 2 minus the n, okay, is also a member of S. Okay, so once again, the quantified piece is here. There is at least one n that's a member of S. So this is the quantified piece of this particular statement. Okay, with the property. So here's the property. So here's the predicate. See, the predicate is dependent. It's dependent on the value of n. So here's the predicate piece here. So this statement is saying there exists. So there exists some n that's an element of S, such that 2 minus n is also an element of S. So this particular statement here, this quantified predicate, is either true or false. So can we find an n that's in S? And don't forget, once again, that S is the set 1. Let me just get that set again here. So it's 1, 4, 7, 3, and 9. So this is saying there exists, that there is something in here where this property is true. So can we find an n in here that 2 minus the n is an element of S? Well, let's have a look at it. So can we find, we're back to 1 as the example again. So 2, when n is 1, 2 minus 1 is 1. And is 1 an element of S? Yes, it is. It is there. So this is actually true. So now we have that this is true. There does exist an element. Let's negate it. So keep in mind, universal quantification goes to existential quantification. And existential quantification, there exists, goes to the universal. And also the predicate, okay, is negated. So we negate the predicate statement that's part of the universe, that's part of the quantified predicate. So now this becomes, there exists becomes for each and every n that's an element of S, we have that 2 times 2 minus n. So the statement needs to be negated. So 2 minus n is an element of S, gets negated. So that means 2 minus n is not an element of S. So is this true or false? Well, it depends on, well, we know the original is true, okay? So its negation must be false. But let's just assess it. So this is saying for all n that's an element of S, when we take the n away from 2, that value is not an element of S. So for example, let's say, so we have to choose 1 to be n. So 2 minus 1 gives us 1. Okay, is 1 not an element of S? No, it's not. Okay, so that's actually false. Okay? Let's take another one, 4. It's the same for them all. Okay, so we found one already, a counterexample. What about 4? Well, we have 2 minus 4 is minus 2. Minus 2 is not an element of S, so it's true for 4. What about 7? Well, 2 minus 7 gives us minus 5, and minus 5 is not an element of S, so it's true for 7. What about 3? 2 minus 3 gives us minus 1, which isn't an element of S, so it's true for that. What about 9? 2 minus 9 gives us minus 7, and minus 7 is not an element of S, so it's true for 9. But hang on a moment. It says for them all, okay? And we see that 2 minus 1 gives us 1, and 1 is an element of S, so this statement is actually false here under that situation. It says for them all, and we found an example where it's not true, so this must be This is now false. Okay, guys. Once again, this was Jonathan Lambert with Maths and Stats. And in this particular video, we've been looking at the negation of quantified predicates. I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for you. And thanks for watching. Okay, bye bye.